So, I want to take a look at logical fallacies. And so often we're presented in the media and culture with particular arguments, and sometimes there's things that just don't quite make sense, or you have this feeling something may be off. And I find it's really helpful to come to something like this. This is the Wikipedia list of fallacies. And what you can do here is look at different logical fallacies that people will make when they're making their case. And you can often use this to go, okay, that argument is invalid. Take, for example, equivocation, the misleading use of a term with more than one meaning by glossing over which meaning is intended at a particular time. You see this a lot with the term immigrants. It's used to mean two things, both the legal and not legal types, but people argue as if you are treating those coming legally into this country as criminals or something like that. So there's all sorts of these that you can look through for yourself, and I want to highlight one in particular because taking a very controversial issue here of climate science, and it's one in particular here. You can see the Ludic fallacy, the belief that the outcomes of non-regulated random occurrences can be encapsulated by a statistic, a failure to take into account unknown unknowns in determining the probability of events taking place. Now, that's kind of a mouthful, but what prompted this is I read this article by this Onar Am, and I was thinking, say you were a millennial and you were brought up through school and you were shown an inconvenient truth, and you were thinking, my God, this is a crisis. The scientists all agree. The science is settled. We have till 2014. The ice is going to start melting by 2020. Some of us are rather disappointed that California has not sunk into the ocean. But there was these catastrophic predictions. And when we're looking here right before the start of 2019, we've seen a great pause, and none of the models predicted it. Nobody in the climate community was saying, well, we've seen a rise in temperature and now it's going to pause for 20 years. And we basically just had to live this series of events year by year to even have this discussion because some of the rhetoric that got thrown around. But I want to take a look at a particular logical fallacy, this Ludic fallacy, and you can see the way there's errors in the logical thinking of things, and so you don't get fooled again, so to speak. What happened? What went wrong? And what do we need to look at going forward that could correct this? So let's just start with this guy's article, published here at Liberty Nation. I'll link it down below. So, former Vice President Al Gore made a ruckus at the COP15 climate conference in December 2009 when he said that some of the models say that there is a 75% chance that Arctic sea ice could be completely gone during part of the summer in only 5 to 7 years. Now, 9 years later, the ice is still there, just like the moderate scientists predicted. It wasn't just this prophecy that failed abysmally. The legacy media has not reported on it, but most alarmist predictions have failed. The Earth did not warm significantly in the last 2 decades, a phenomenon that scientists refer to as the pause or hiatus in warming, and the weather has not been getting more extreme. Currently, the climate science community is in the awkward space between recognizing that warming has slowed down and acknowledging that this implies that the computer models are wrong. Okay, Donald Trump has referred to it as a hoax. And it was something highly ideological motivated scientists inserted themselves at the center of the Intergovernmental Panel on Climate Change, the IPCC. They wanted to be right and made a few shortcuts. So here I want to take a look at this graph, and you can see here we go back 1,000 years, and this is all blue here. This is blue, and then this last little spurt here, this last couple hundred years, is in red. And it's hard to see, but it says data from thermometers red, and from tree rings, corals, ice cores, and historical records in blue. Okay, so the point being here, the thermometer wasn't invented until like the 1700s. And so, Al Gore didn't actually build a time machine and take his thermometer back and measure the climate at all these different points in history. These are inferred data points. Okay, they are using what's called a proxy. The tree rings, or the rings on a tree, coral, ice core, these are proxies for the temperature. They give you an estimate of what the temperature has been. And so there's a variability in how reliable this data here even is. So we can see if we look up here, the point of concern starts in the 90s, and we're talking about 0.5 degree Celsius being this spike here right at the end, which is about 1 degree Fahrenheit, 0.9. So you think, okay, we have accurate records here with the thermometer, but prior, these are all data points that are determined by proxy. So let's go on with the article here. In 2000, IPCC was still heavily influenced by objective scientists, but in 1999, Dr. Michael Mann published a paper with a graph that became the poster boy of climate alarmism, the hockey stick graph. Okay, this is what we see here. This spike, and the assertion was it was just going to continue here, higher and higher and higher, out of control. It was rushed through peer review and plastered all over the IPCC's third assessment report in 2001. After this, no one was allowed to doubt that humans were dramatically altering the climate. There was only one problem with it. Man was incompetent, and the conclusions were bogus. A Canadian engineer called Stephen McIntyre started doing what no one else had done before. He looked at the data and tried to recreate the result. And so I want to take an aside here and talk about a mathematical concept called extrapolation. Now that's what we're doing here in my little addition, is you're taking the trend and you're assuming that it's going to continue. But we don't have any data here. This was in the future at the time. So these are educated guesses at best. Looking at the definition, in mathematics, extrapolation is the process of estimating beyond the original observation range the value of a variable on the basis of its relationship with another variable. It is similar to interpolation, which produces estimates between known observations, but extrapolation is subject to greater uncertainty and a higher risk of producing meaningless results. Extrapolation may also mean extension of a method, assuming similar methods will be applicable. Extrapolation may also apply to human experience to project, extend, or expand known experience into an area not known or previously experienced, so as to arrive at a usually conjectural knowledge of the unknown. So here we can see a little graph. There's these red data points. This is actual data. And if you're following the curve here, this blue square is an unknown, but it would be the extrapolated point. It would be if you expected this trend to continue goes up, and it's coming down. You extrapolate to this point here. Now, when I was in high school, they taught in math, extrapolation is the most dangerous thing you can do in mathematics. And you can see here, it is subject to greater uncertainty and a higher risk of producing meaningless results. Now, this is just a theoretical set of data, but what's to say this isn't, say this is, I don't know, a stock price or home prices. What's to say you don't get a bounce here? This is a sine wave or whatever's going on. When you're extrapolating limited data here, you are taking a risk, and that's what they are doing here with alarmism. Where's my pen? They're taking the risk that, okay, we are pumping more CO2 into the atmosphere, so this spike is going to continue ever upward. You can see this here. This is Al Gore, and so there's the CO2. The CO2 is going up, and it seems to marry on fairly clearly onto the increase in temperatures. Now I want to make another point, looking back up here, on all this data that is collected before the invention of the thermometer. So using these proxies, we're going to go back to the Ludic fallacy. We don't know the unknown unknowns. So how did we get this data point? Let's take a particular data point, 1000 AD. Okay, the Vikings are raiding England right here. We have a collection of tree stumps that we're looking at, and we're looking at the rings, and we estimate that, okay, the global temperature is roughly at this point. But the problem is when you're modeling that data, what else could affect tree rings? Okay, well, it could be the soil around the tree. It could be, maybe it was a cold year, but there wasn't a lot of clouds, so the trees were getting a great deal of sunshine. Maybe it was, any various things that would give you this particular tree ring. I mean, there could have been volcanoes. There could have been, and really you can go, maybe the tree has evolved so that it grows differently here in, 1850 than it did in 1000 AD. And so different amounts or different levels of global temperature actually would create different levels of growth in the tree rings because the tree has actually changed with the environment. And I guarantee you that they're not taking that level of depth when they're analyzing these rings. How many tree rings do you study? How many different locations are you looking at? And again, they are taking a localized sample of data and they are extrapolating it to a larger area. They're extrapolating that to the global temperature in the Earth. So they're not just extrapolating here. This is not just what's being done in this set of data. They're actually extrapolating into the past as well, because these are also unknown points because there was no technology to measure it. So they use these proxies. So you have these variable points of what could have been an error in their calculation. And so they select around the middle. But you start looking at these points of variability. And what if you were not trying to get a hockey stick and you start going, well, maybe if we assume it was the warmest possible, you start getting situations. There's a medieval warm period. Okay, there's a cooling period. And you start to assume the warmer situations. And then here you want to interpret, well, what's the low end of the data? All of a sudden your hockey stick looks like that. That's a much less scary graph. And you can do it using the very same data that these scientists have used. Tree rings, I think, are that's a tough one to rely on. Coral, I don't know much about. Ice core, keep in mind, this is a proxy being extrapolated from a localized region to the entire ocean, say in the case of coral, or the Arctic region in the case of ice core, and then you're extrapolating that again to the entire climate of the whole planet. So really, the amount of known data that we have is kind of like right here. And all the rest, you're not only extrapolating forward in time, you're extrapolating backward into time. And so this graph can be made to look scary. But when you realize how much of it is conjecture, how much of it falls into this variability, you got to go, well, why didn't the models work? Well, because they took a particular set of assumptions with this data that created this convincing looking scary hockey stick graph. But this data could have been drawn up in a very different way, and we really don't know exactly how much variability there is between, say, the coral growth and what that temperature corresponds to. It's an estimate. So let's go back down. We're going to look at Al Gore. We're going to look at Al Gore. He's smiling because he's saving the world here. This is a little easier to similar graph, same graph. You can see the spike here in 2000, and that was what was all the cause for alarm. Now here's ice core data. There's the down here we can see the ice age. We came out of the Great Ice Age, and then your hockey stick is right about there. Okay, and that actually does not look that dissimilar to our scribbling up here, where we took the warmer end of a lot of estimates. So, go back down, look at our hockey stick. This is ice core data. Okay, here's another graph. This was July 2018. We're looking at about 0.32 degrees Celsius of warming. So I want to look. This is the spike here where Al Gore was very concerned, and then this is kind of what we've seen. We saw a reversion to the mean almost around 2000. This models a lot the stock market. If you look at the year 2000, the spike we saw, and then come down here, and this is referred to as the Great Pause. You see, we've kind of just been bouncing around, and the technology we've got is a lot better, so the measurements are getting more reliable. And you can do this all day. You can cherry pick data. The point isn't to talk about cherry pick data. The point is to talk about the fact that when you're attempting to model all the errors that can be built into these models due to human interpretation, due to the fact that you're not taking all of the variables into account, because a model can't do that. You're always going to throw out some data, and you're going to keep some data. You're going to have to make those decisions because these models are determined by human beings. And so you get kind of some of the silly claims. Al Gore claimed in 2006 that by 2016 Kilimanjaro in Africa would be snow-free. And of course that didn't happen. None of these models, particularly Al Gore, they did not predict the 15-year hiatus in warming. That's what you're looking at up here. And incorrectly predicted in 2008 there would be no Arctic ice by 2013. That's very famous. And the problem with a lot of these climate predictions is there was all of these catastrophes, but we're now reaching the point where we're hitting these years where things were supposed to spiral out of control. We would be past the point of no return, and we're not seeing it. And so one of the things you got to realize if you're going to be an advocate of global warming is, one, you've got to prove that it's true. You've got to prove that the Earth is warming. Two, you have to prove that it's CO2 that is causing the warming. Three, you've got to prove it's man's contribution to CO2 that is the problem. And four, you have to prove that your proposed solutions are actually going to lower the CO2. And we got to have a way to test that. If we're going to get carbon credits, if we're going to sign the Paris Climate Accord, you got to show exactly how that's going to work, what we're going to expect to see, and be able to show the global temperatures declining. And then go, okay, yes, this policy works. No, this policy doesn't. What's wrong? And the problem is we're still at step one, trying to establish if there's any warming at all. So basically, when you're dealing with extrapolation, you're kind of just, in best case scenario, it's educated guesses, and worst case scenario, you're just reading tea leaves. And here's a fortune teller divining this woman's future, telling her, she's going to meet her husband at the market here, and they're going to have 3 children or something. I mean, really, and when you consider the fact they're not only extrapolating the spike at the end, they're extrapolating a good chunk of the previous data. Maybe they're pretty good, but what is their margin of error? Is it half a degree? Well, that wipes out a lot of what this spike was. That was only about 1 degree Fahrenheit. What is it? Is it a margin of error of 1 degree, 2 degrees? I mean, it hits a point where just your margin of error is accounting for all of the so-called warming, all of this so-called hockey stick. So how did Michael Mann respond? Did he say, well, look, here's my evidence, here are my facts, here's the data, here's how we arrived at it, this is the scientific process, this is what we kept, this is what we threw out? No, he resorted to attack. So Michael Mann tried to smear him, but after many years, one of the leading statisticians in the U.S., Edward Wegman, was commissioned by Congress to write a report on the hockey stick graph. The Wegman report was a devastating blow to the credibility of Mann. The report demonstrated that the method he had used to produce the hockey stick graph could be used to create any shape you wanted, and we've kind of shown how you could do that. So here's a little funny cartoon. The cover-up. The Wegman report should have ended Mann's career, and many people in the IPCC should have lost their jobs for sloppy work and incompetence, but instead, because they have the media on their side, they're around, because this forwards a political agenda that's of service to the left. I mean, that's no surprise. We need global communism. Let's see. Then in 2009, someone leaked emails from this group of tightly knit scientists, and they showed less than an honest handling of the situation. Again, not what you would expect from people that are presenting truth. Just present the truth. Just show us the facts and go, well, I guess the Earth is warming. So rather than dealing with the matter in a scientifically rigorous manner, they tried to cover it up. This leak has been referred to as ClimateGate. We do not have similar information from other areas of climate science, but some of the behavior we observe is consistent with fraud. The 97% consensus, one example is the claim that there is a 97% consensus among climate scientists. What is rarely mentioned is that most so-called climate skeptics fall within that 97%. Most skeptics do not believe that humans do not affect the climate. They merely say that the warming is small enough to be of no concern, which is at least what we've seen over the past 20 years. Why did the alarmists have to falsely boost their credibility with inaccurate claims about how many scientists support their position? One thing when I see this number, I think of an advertisement for toothpaste. 9 out of 10 dentists prefer Colgate over any other competitor. And I don't know if you're like me, don't you wonder what that other one dentist recommends? Like, why isn't that guy on board with the other 9 dentists? I mean, what does he know that the others don't know? Is it that the fluoride's poisonous? Does he think Crest is better? Are these 9 guys, these 9 out of 10, are they just paid by Colgate? Did they cherry pick their dentists that were going to say that they like Colgate better? I mean, this is the common sense sort of analysis that everybody does when they see a commercial, but for some reason when it's presented in this fashion, it's like they turn their critical faculties off, and I just wonder, it's like they so badly want it to be true. I don't know, but this sort of thing, this is just an advertising ploy at this case, because do they all agree exactly on one model? Well, no, they don't. There's all sorts of ideas that, what does this consensus mean? Consensus about what? Is it consensus that the Earth is warming? Is it consensus that CO2 is causing the warming? Is it consensus that the Paris Climate Accord would be successful in bringing the warming back down? I mean, it's quite vague, particularly for scientists. So let's see, the temperature adjustments. Another example is the continual adjustments made to the historical temperature data. There are many error sources in temperature measurements that can cause false trends. Population growth, more asphalt and buildings and other things all produce spurious patterns and data over time, and they therefore must be corrected. Okay, that's something we kind of talked about with the tree ring issue. There's a lot of things that affect how much that tree grows. And, maybe a woolly mammoth died next to it and it had a whole bunch of extra nutrients. Some of the corrections in data, this is a hard graph to see, but I think this is kind of your medieval warming period. There's been a lot of controversy. Sometimes it looks like that, sometimes it looks like this, and then the little hockey stick, is just a little bump next to that. And it's because they're using these proxies rather than nobody had, the Knights Templar did not have thermometers that they were waving around at the Crusades. So let's see. Most of the known error sources, however, produce a false warming trend, and therefore the data need to be adjusted downward. However, since 2008, the National Climate Data Center has been producing modified data sets with the opposite effect. So basically what they're saying is these cold periods in the past are getting colder, and then the increase since the Industrial Revolution is getting warmer. Let's see, the graph shows the changes made to the data lately. Notice how the past has become cooler and the recent decades have been made warmer. What are the odds that every time a new data set is released, they have found some more warming? The behavior strongly resembles a pattern seen in elections in some districts where there is a close race between Republicans and Democrats. Time after time, if a Republican wins, someone finds some lost or late ballots. They mysteriously turn out to be almost Democrats. Yeah, we've seen that. Vigilance is needed. It could very well be that the temperature adjustments are scientifically sound, but if it were fraud, this is precisely what you would expect to see. They leave the strong sense that many career alarmists are worried about their future and reputation, and that the actions are being made to change the observations so they are in better agreement with the climate models. Since the legacy media is staying wholly silent and uncritical of the climate community, it is vital to remain vigilant and remind people of the dubious nature of their endeavor. The science is not settled, and there is even a chance that the greatest scandal in scientific history is in the making. So we're going to look at this Ludic fallacy, because how could you have seen this coming? So the Ludic fallacy, identified by Nassim Nicholas Taleb in his book The Black Swan, is the misuse of games to model real-life situations. Taleb explains the fallacy as basing studies of chance on the narrow world of games and dice. The adjective ludic originates from the Latin noun ludus, meaning play, game, sport, pastime. The fallacy is a central argument in the book and a rebuttal of the predictive mathematical models used to predict the future, okay? Like climate models. Extrapolation, that's the issue we talked about earlier. As well as an attack on the idea of applying a naive and simplified statistical model in complex domains. For instance, the climate. There's so many inputs that go into the climate, one of the biggest ones being the sun itself. How many of the studies do they look at the state of the sun? Is it shooting off a bunch of solar flares? What's going on there? Do they have models going back 1,000 years or 10,000 years that explain solar behavior? I don't know, but it doesn't seem to be what they're doing when they look at tree rings or coral or any of these other things. According to Taleb, statistics is applicable only in some domains, for instance, casinos in which the odds are visible and defined. So a casino is very simple rules, blackjack, 21, poker, Texas Hold'em, a straight, three of a kind. It's not modeling the climate out there. It's I have an ace and a king, or I have a king and a 9. Hit me? No, probably not. Taleb's argument centers on the idea that predictive models are based on platonified forms, gravitating towards mathematical purity and failing to take various aspects into account. And that's where we talked about all the variation. Using the tree example, there's a lot of things that can make those tree rings bigger than just warmer climate. So that explains a lot of that variation when you are using proxies. So, 1, it is impossible to be in possession of the entirety of available information. Small, unknown variations in the data could have a huge impact. Like I said, what if those trees have evolved over time to grow faster with less sunlight? Well, then when you're looking at that tree 1,000 or 5,000 or whatever, 5,000 years ago, it may only say it sets your model off by a 1/10 of a degree. But when you're extrapolating that information far back into the past and into the future and you're trying to make a model, well, you have a 1/10 of a degree that your tree ring model is off. Well, you also have a small mistake in your coral model, and your ice core has some variation. And all of a sudden, your model is way off, and you're looking for huge warming in the year 2014, and Mount Kilimanjaro is not supposed to have any ice. And then you look, and here we are past 2014, and it still has ice and snow on Kilimanjaro. And so what caused that? Why was the modeling wrong? Well, this is what Taleb offers here. Theories or models based on empirical data are claimed to be flawed, as they may not be able to predict events which are previously unobserved but have tremendous impact. Okay, 9/11 and invention of the automobile. This is in his book Black Swan, and I highly recommend the read if you're interested. But what could be a black swan if you were studying climate? It could be a large volcano. It could be a flare on the sun. It could be very cloudy weather. It could be an excess of rain. It could be a lot of things that you're not capturing in your proxies when you're trying to model the data. So an example in this Ludic fallacy, he gives the suspicious coin. 2 people are involved. There's Dr. John, who is regarded as a man of science and logical thinking, and Fat Tony, who is regarded as a man who lives by his wits. A third party asks them to assume that a coin is fair, i.e. has an equal probability of coming up heads or tails when flipped. I flip it 99 times and get heads each time. What are the odds of my getting tails on the next throw? Dr. John, okay, Mr. Scientist here, using the proxy data, is going to say the odds are not affected by the previous outcomes, so the odds must still be 50-50. That is mathematically the correct answer. However, Fat Tony says that the odds of the coin coming up heads 99 times in a row are so low that the initial assumption that the coin had a 50-50 chance of coming up heads is most likely incorrect. The coin gotta be loaded. It can't be a fair game. The Ludic fallacy here is to assume that in real life, the rules from the purely hypothetical model, where Dr. John is correct, apply. Would a reasonable person bet on black on a roulette table that had come up red 99 times in a row, especially as the reward for a correct guess is so low when compared with the probable odds that the game is fixed? In classical terms, statistically significant events, unlikely events, should make one questions one's model assumptions. In Bayesian statistics, this can be modeled by using a prior distribution for one's assumption on the fairness of the coin, then the Bayesian inference to update this distribution. Example in fighting, Nassim Taleb shares an example that comes from his friend and trading partner Mark Spitznagel, a martial version of the Ludic fallacy. Organized competitive fighting trains the athlete to focus on the game, and in order not to dissipate his concentration, to ignore the possibility of what is not specifically allowed by the rules, such as kicks to the groin, a surprise knife, and so on. So those who win the gold medal might be precisely those who will be most vulnerable in real life. It's the idea that, you might be great at MMA, but I can just carry a pistol. So I pointed out this, you can apply the Ludic fallacy. You can get these small variations in the data that may have been responsible for the Great Pause instead of the huge out-of-control warming we have supposed to have seen. But it's not just the little math. It's not just the tree rings or the evolution of the tree over 1,000 years or improperly using the proxies that has gone wrong. There was recently a major scientific calculation error here, and it had to be addressed in Nature magazine. So this was, this was by this Joshua Emerson. He writes, researchers with UC San Diego's Scripps Institution of Oceanography and Princeton University recently walked back scientific findings published last month that showed oceans have been heating up dramatically faster than previously thought as a result of climate change. In a paper published October 31st in the journal Nature, researchers found that ocean temperatures had warmed 60% more than outlined by United Nations Intergovernmental Panel on Climate Change. However, the conclusion came under scrutiny after a mathematician, Nick Lewis, a critic of the scientific consensus around human-induced warming, posted a critique of the paper on the blog of Judith Curry, another well-known critic. The findings of the paper were peer-reviewed and published in the world's premier scientific journal and were given wide coverage in the English-speaking media. Despite this, a quick review of the first page of the paper was sufficient to raise doubts as to the accuracy of the results. Co-author Ralph Keeling, climate scientist at the Scripps Institution of Oceanography, took full blame and thanked Lewis for alerting him to the mistake. When we were confronted with his insight, it became immediately clear there was an issue. We're grateful to have it pointed out quickly so we could correct it quickly. Keeling said they have since redone the calculations, finding the ocean is still likely warmer than the estimate used by the IPCC. However, that increase in heat has a larger range of probability than initially thought. Between 10 and 70%. That's a large range. Our margin of errors are too big now to really weigh in on the precise amount of warming that's going on. So this isn't settled science. This is a climate scientist right now saying that they can't even get the amount of warming going on right here, right now, in the present, down to any sort of reasonable margin of error. How well do you think they have modeled the climate in the past? And Keeling said we really muffed up the error margins. So a correction has been submitted to the Journal of Nature, questioning the science. That's what you do with science. According to the most recent IPCC report, climate emissions need to be cut by 20% by 2030 and zeroed out by 2070 to keep warming from exceeding 2 degrees Celsius, 3.6 degrees Fahrenheit above pre-industrial levels. Okay, you can take that as absolute gospel. You can question that. It really is not important to looking at the Ludic fallacy, which is my main point here. So here's something, though, we can mark this and see what happens. Authors of the study previously claimed emission levels in the coming decades would need to be 25% lower to keep warming under that 2-degree cap. So this is something we can see coming decades. So that could be 20 years, 30 years, 40 years. It's not real specific, but let's see if we heat up that 2 degrees or not. Okay. And this is their defense. This is how the process works. It's not bulletproof. It's not infallible, or you could say it's not settled. If it doesn't stand up under scrutiny, you review the findings. And that's what we're seeing with climate science today, and it is a result of this Ludic fallacy. Okay, much of the data on ocean temperatures currently relies on the Argo array, robotic devices that float at different depths. The program, which started in 2000, has gaps in coverage. So if you remember that graph we saw at the very beginning, here's the pre-thermometer, and there's the 1990s. Okay, even here in 2000, the methods we are using to measure climate right now have gaps in coverage. Okay, and that's starting in 2000. So this period of time here, you got to definitely take with a grain of salt. Remember, they extrapolated not only into the future and were wrong, but they also extrapolated into the past, which gave them the cool little hockey stick formation we see here. By comparison, Keeling and Laura Respondi, a researcher at Princeton University Environmental Institute who co-authored the report, calculated heat based on the amount of oxygen and carbon dioxide rising off the ocean, filling round glass flasks with air collected at research stations around the globe. Keeling said they will continue to experiment with the data in coming years in an attempt to fine-tune the data, or they're trying to get down that margin of error, which is respectable. But, what about the tree rings? Who knows? It's a promising new method, but we didn't get the precision right on the first pass. The study is still to confirm that the ocean is warming using a method independent of direct ocean temperature measurements. All right, so here is an article. It was by Repairman Jack. Okay, and he talks about this Ludic fallacy in modern American climate science. And that, here it is again, assuming flawless statistical models apply to situations where they actually don't. This can result in the overconfidence in probability theory or simply not knowing exactly where it applies, as opposed to chaotic situations or situations with external influences too subtle or too numerous to predict, and then you extrapolate them out. And it's like a ship in the Atlantic Ocean back when they had to sail by compass. If you were off by 1 degree, you might set sail for Cuba and end up in, South America somewhere. One small error, and you don't know which one necessarily, because they're taking their proxies from so many different points. One small error can get them in a dramatically different place. So one of the consequences of this is you get sort of the embarrassing situation with the head of the EPA, EPA chief Gina McCarthy, when she squared off with Jeff Sessions. So if you're getting put in your place by Jeff Sessions, you're probably doing something wrong. Jeff Sessions says, would you acknowledge that over the last 18 years that the increase in temperature has been very little and that it is well below, matter of fact, 90% below most of the environmental models that showed how fast temperature would increase? And this is McCarthy, this is the EPA chief responding. I do not know what the models actually are predicting that you are referring to. And Jeff Sessions' response, this is a stunning development that the head of the EPA, who should know more than anybody else in the world, who is imposing hundreds of billions of dollars in cost to prevent this climate temperature increase, doesn't know whether their projections has been right or wrong. And that is, she worded this strangely. I do not know what the models actually are predicting that you are referring to. She doesn't know that the models are predicting the hockey stick catastrophe. I mean, isn't that the whole point of dealing with global warming? That is a stunning announcement. Okay, and so this is the author going back. These very same models have been the centerpiece of the entire argument that our planet was threatened with catastrophic global warming. Okay. And this is the IPCC, the UN, of course, in 2007. Warming of the climate system is unequivocal, as is now evident from observations, apparently not the observations that the EPA was aware of increases in global average air and ocean temperatures. Okay, those things we've got floating in the water at different levels that have gaps and are not providing us with the information we want. Widespread melting of snow and ice. You know, this can be very scary. Snow and ice does melt every single year. It's been happening on Nature Channel since I was a kid. And rising global average sea level. I don't see how much has it risen. How do they calculate this? Was the tide just coming in? Who knows, right? The scientists were so certain that AGW was settled science that they unleashed the following claim. When the effect of GHGs is removed, bootstrap simulation of the model reveals that there is less than a 1 in 100,000 chance of observing an unbroken sequence of 304 months with mean surface temperature exceeding the 20th century average. Now, there's another fallacy in there, but I'm not so interested in that. I'm just, I don't think there's anything else in this article. When reality disagrees, scientists rerun their models. The models repredict what they are mathematically ordered to. What are you going to believe, your lying eyes or the computers you are paid to program? And so, images. I'll put the link to this article. You can read it. That will be down there as well. But it's just to give you an example why you need to be skeptical, and that's part of being a very reasonable person on anyone that's modeling. I was in high school in the 90s, and there was the tech boom in the stock market. And the stock market did something like this. And this was about 2000, March, April of 2000. And imagine you gave someone at this point in time, they showed you this graph and they said, this is our performance. This is, if you give us $100,000, we'll invest it for you. Look at this track we're on. It's just going to continue going up, up, up. And your $100,000 will be worth $1 million. Give us 20 years. So you think, well, yeah, $1 million in 20 years sounds pretty great. So there's $1 million right there. And so you give him your money. He's got his statistical models, the stock market just booming. And you give him the money and you go about your life. And now it's coming up on 2019 and you say, well, can I have my $1 million? It's been 20 years. You showed me those models that worked out so well. And he goes, well, the models didn't quite work as expected. And you say, okay, well, what does that mean? And he says, well, basically, we still got your $100,000. We can give you that $100,000 back. You have to ask yourself, is this a person that you would continue to let invest your money? Or would you realize very rationally that these models have been wrong and this person is untrustworthy? And when you look at the projections that you were going to be a millionaire, you would have to consider the wisdom of Yogi Berra when he said, the future, it ain't what it used to be.